Good day to our lecturer, Dr. Muhammad Hamizi. We are Tesu Yang, Xiao Ziheng, Fong Lik Sing from EEM353 Group 9, and today we will present about the autonomous gate system.
Autonomous gate system has been around since the 19th century, where electric motors have been replacing manpower in the operation of various types of gates. As the world becomes more advanced, more security measures have been applied into gates to increase the security and keep the unauthorized people away. This report aims to design an automated gate system in households which includes the usage of microprocessors, sensors, and actuators, specifically Raspberry Pi 4, IR sensor, camera module, and suitable motoring system, as well as software and programming applications using Linux OS and Python programming language.
There are two motivations of our group project, Smart AutoCADs. The first is the home security. The security level in home can be increased by the autonomous car plate recognition system, which can verify the user's car plates before open the gates. Then the second one is the Smart AutoCAD is user-friendly. The user does not need to open the gates manually or by using the remote control, since the Smart AutoCADs will open the gates automatically after the verification process.
The development process is divided into a few parts, namely planning, concept development, system level design, detailed design, testing and refinement, and also production ramp up. In general, the responsibilities are split into a few sections, which is marketing, design, manufacturing, and other functions such as research, finance, and general management. In this process, the planning goal is to integrate and automate the electric gate system using various sensing hardware modules as input to control the output, which is the electric motor of the gate, in which required hardware to do so. The system also includes implementation of microprocessing units with the suitable operation systems and programming language to control the peripherals. Hence, a software developing team is required. In the design section, the prototype is built on recycling materials such as cardboard and paper straw. The design was first conceptualized in the 3D CAD software, which in this case the 3D CAD used is Autodesk Fusion 360. After design was finalized, the sourcing of the hardware is carried out. The components are bought and sourced out based on the budget planned by the marketing and financial team. The next step is, after sourcing out the hardware components, is the software development process. By working with the hardware team, the operating system was installed into the microprocessing unit, and the system has program based on Python language. When the software development is done, the prototype is assembled into one piece and tested out. Suitable data will be collected and be future processed for improvements and adjustments. The last step of the system development was done is to communicate with the customers to plan out the production operation of the system. There are 6 steps in opportunity identification. First is establish a charter. The charter for the automatic gate system is to create a full-size physical products of the system that are able to release into the market within 3 months through various sales channels including online shops and also retail shops. Second step is to generate and sense many opportunities. Discover many opportunities in the Horizon 1 and Horizon 2 opportunities. In the end, the options are filtered down into 3, namely Horizon 1 opportunity, autonomous gate using RFID card, Horizon 2 opportunity, which is autonomous gate using iris biometric identification, and lastly Horizon 2 opportunity also, which is autonomous gate using automatic license plate recognition ALPR. The third step is screen opportunities. After many discussions, feedbacks and reviews, the team decided to go with a certain automatic identification system without the use of security card. The fourth step is to develop promising opportunities. The aim is to collect more data through different channels into the project to reduce the uncertainty regarding the opportunities selected. The fifth step is the select exceptional opportunities. The basic concept used here is the real win worth it method, the RWW. The last step is to reflect on the results and process. This is the last step of the opportunity identifying process. The questions asked are how many of the opportunities identified came from internal sources versus external source? Did we consider dozens of hundreds of opportunities? Was the innovation charter too narrow focus? Were our filtering criteria biased or largely based on the best possible estimates of eventual product success? And lastly, are the resulting opportunities exciting to the team?
My name is Fong Lik Sing with metric number 148574. So right now we will undergo the process of product planning to create our product. The 5 steps are shown here. The first step is identify opportunity. Through opportunity identification, as discussed previously by Tae-Soo Yang, three ideas generated internally within us. The ideas such as the autonomous gas using RFID card, iris biometric identification, and license plate recognition. And then the second steps are evaluate and prioritize projects. The first factor we consider are the cost, as the iris biometric recognition requires the highest cost of production, so we eliminate these ideas. After that, we use the technology S-curve to do further filtration. From the S-curve, we notice that the ALPR technology still have a lot of room for improvement compared to RFID card. So finally, we decide the autonomous gate system by using ALPR technology become our promising project. The third step is allocate resources and plan timing. By using this step, balanced distribution of work is done between team members, and the introduction date of the autonomous gate system also has to be announced as soon as possible to avoid customer lost interest due to outdated technology. And we also can do further improvement for the products earlier. And the fourth step is complete pre-project planning. The mission statement is required, and this will be discussed in the next section by my teammate. The mission statement is provide the clear guidance for us to what we should focus on. So for the last step is reflect on the results and the process. Several questions can be asked, such as is the promising project chosen correctly? Are the mission statement assigned correctly? How to improve the results and the process for the autonomous gate system?
Now, we're going to the customer needs. There are some ways for our groups to determine the customer needs. First, we define the scope by using the project mission statement, which include the describe about the smart auto gates, set up the key business goal, set up the target markets, and make assumption to the technology used. And last, we state all the stakeholders. Next, we gather the raw data from the customers. We have an online discussion with the extreme users, and the Google Meet is used as our template. 10 ringgit is given to each participant after the discussions. Next, we also interpret the data collected into customer needs. All the customer statements that we collected are interpreted to the needs on the design of the smart auto gates. Then, we will organize the needs into hierarchy, which each of the needs of smart auto gates are wrote down on a separate piece of paper. Then the unnecessary statement will be eliminated, and the card will group into the similarity needs. So each group will be labeled, and after that a super group is created, which include of a few groups. After that, our group established the importance of needs, which a survey about the customer interest on the AutoGate is done among the 50 users, and the data collected are arranged into a bar charts. Then the last, we reflect on the process, which a perfect smart AutoGate, which implemented with an autonomous car plate recognition system, is created and designed based on the needs of customer.
So right now we'll talk about the product specification. The processor we use is Raspberry Pi 4 Model E. Motor drive module is L298N motor drive module. Infrared sensor with operating voltage between 3.6 to 5 volt, measuring distance between 2 to 30 cm, and motor is high torque DC gear motor, Pi camera with 5 megapixel, power supply, any 24 DC supply and home power supply, and gear with 12 module with 30T and pinion with 12 module with 3200 Nm.
The software we use are the Python, Firebase, and SolidWorks. This is the diagram of our mechanical design of the smart AutoGate system, which include the gates, the range sheets, the steel roots, the pinions, the racks, roller, and also the motor box, which include the motor drive modules, and Raspberry Pi module. Then under the range sheets, there is a Pi camera, which functions to capture the image of car plates. Then they also got the two infrared sensor to detect the presence of vehicles.
So right now it's a block diagram. The input are IR sensors and Pi camera, output are motor drive and a motor. And the Raspberry Pi 4 acts as the brain of the system, which interfaces between input, output, programming, and Firebase, and power supply is supplied to Raspberry Pi 4 and the motor drive. The flow of function of autonomous gate system is shown in this flow chart. This is the electrical circuit of the autonomous gate system. The voltage pin, ground pin, and the signal pin of IR sensors and the motor drive is connected to the pin of the Raspberry Pi, and the Pi camera is connected to the CSI port, and the motor is connected to the motor drive to control the counterclockwise and clockwise movement. We also require to do the calculation and analysis to calculate the minimum torque required by the motor to move the gate. So first, we need to draw the free body diagram of the gate, and then we can find out the reaction force act on the gate is 651.7 Newton. After that, we can calculate the reaction force act on the roller, which is the 702.8 Newton. So by using this formula, we can find the frictional force of each roller, which is 11.7 Newton. And finally, we can find the torque required by the gear, which is 4.5 Newton meter. So we have to ensure that the motor we choose have at least 4.5 Newton meter in order to move the gear. So right now, I will talk about the robust design. The robust design is needed to meet the customer expectation and can avoid variation that cause quality loss. So first, the DC motor used in this system might not have enough torque to open the gate, so detailed calculation is required to find the minimum torque of the motor. And second is the identification of the vehicle plate number might not be so accurate. So in this paper, we modified the Pi tesseract code to increase the ability of the system to read the vehicle plate number. So finally, the autonomous gear system using ALPR technology is successfully being implemented. So for future improvement, the high resolution of camera and face recognition system can be added into the autonomous gate system in order to increase the security and automation.
When the car plate is recognized, the motor will turn the pinion counterclockwise to open the gate. Then after that, when the car leaves the detection area, the motor will drive the pinion clockwise to close the gate.
So right now I will demonstrate the software powered system. So first is Firebase. Firebase is used to store the data of the vehicle, and then the Python. Python is used to program the system. So first, let us try the vehicle car plate, which is stored inside the Firebase. At first, the camera will take the photo of the vehicle, and then image processing will start to do their work, which first it will do the grayscale of the image, and then find the contour of the image, and then it will find the location of the car plate and extract the car plate, and then it will read the car plate and compare with the data stored inside the Firebase. As the data is inside the Firebase, so the gate will open. So right now, we will try for the vehicle which do not store inside the Firebase. So the process are the same. It will do the image processing, find the contour, extract the car plate, and then it will read the car plate and compare with the Firebase. As this is not stored inside the Firebase, so the gate will not open. So that's all from me. Thank you. So that's all from group 9, and thank you.